Hello. Hey, everybody. All righty. So what we are looking at right here is my print bed. That's right here. You're looking from the top down. And I got a little pain on my fingers. I was painting a room earlier. So this is the head that moves around, and I've already got it partially taken apart. And the way this normally works is there's what we call a hot end. And this is a part of that hot end here. And there's a heater that goes on the end. And this goes around and it basically draws whatever we're printing as it pushes out plastic that comes in these spools. And this is a type of plastic called PLA. And so that moves around like this. Now, what's happening is you can see that part of my print right here is nice and red, and then over here you see that there's nothing, and it's kind of a red haze. And what's happening is the plastic that's going through this heat sink, this is supposed to dissipate the heat so that the plastic doesn't melt too soon. So the plastic comes in up at the top, and then at the bottom there's the heater, which I've got over on my workbench. And this is supposed to dissipate the heat. There's a fan, pop this off. There's a fan that attaches here. So this sits just like that in the print head, and this is what moves around. And so what's happening is, because I've got a bad thermistor, it's basically a thermometer, the plastic is starting to melt too high up in the tube, and it's causing jams. So I've got this one all cleaned up. This is the heat break. I've got this all cleaned up, and over on my workbench I've got a new thermistor in some epoxy being ready to mount it, but we've got to get the old thermistor out. So this is what we're looking at here. This is the fan that would attach to this part here, and this is the old thermistor. You can see that there's not much left of it right here. And then this is the actual heating core. So this is what gets really hot. This gets around 400 degrees for what I'm using it for, 450. So we are going to have to remove these black and red wires, because this is the thermistor. And this is what measures the temperature and helps to control how hot that heating core gets. So we've just got to undo it from the braid. I believe this is the second thermistor I've had to replace. I take that back. I had to replace one on a different printer. So this is the first one for this printer in about 6 years. And I think the reason why it went out is because down here at the end, these wires are really, really thin, and just over time, they move around and wear out. So we are going to attempt to get those out of there. And if worse comes to worse, I will just leave them in here. Actually, I think that's what we're going to do. We're just going to leave them in that braid. They're not going to hurt anything. There's going to be a dead wire. So for now, I'll just cut that off, and we'll detach it from the other end. Bingo. So we'll just cut those off right here. These are no good, so just throw it in my old trash bucket. Okay. So these are the arms. They are mounted on just like these little magnetic ball joints, and they can move all around. So what you're going to see is you're going to see these flopping all over the place here in a second. So I'm going to move these, because what we have to do is we have to flip the printer upside down. So we're going to take the plastic spool off, hang on to it so it doesn't unravel. Bingo. And then we'll try to do this without messing the arms up so much. Unhook the wires. I've done some modifications to this printer already. So one of the modifications is adding this silver plate down at the bottom, which is a heated bed. I just broke my spool arm. It's all right. What's one more thing to fix? All right, so got some power supplies I'll have to set up here at the top. You can tell that my board is still hooked up. You can see everything blinking here. So I'll zoom back out. So this is what the underside of the printer looks like. These right here are the power supplies. The cord on is just real short, so I got to set them up here. And my camera is sitting where I usually set them when I do this. Come up here a little bit more. All right, so what you're seeing is the board for my 3D printer, and it looks pretty complicated, but it's really not. This big black board is what's sending the signals to everything, and all the information is held here. And this is a kind of a version of an Arduino board, and then they're bridged together with what we call a BeagleBone. And this right here, this is one of the 4 stepper motors that are on this printer. So these big black boxes are motors, and inside of them there's steps. And so we can accurately turn the pulleys, and that's what moves the arms. So what we're looking for here is we need to get that thermistor unhooked. Now this printer, because I did do an upgrade on it and put that heated bed, has 2 thermistors. And they should be hooked up over here. Now, because thermistors are just measuring a resistance change between when the temperature is hot, when it's cold, and that's how we get the data back, there's really no positive or negative on it, but I've got to figure out which one is which. And if we look down in here, try to move the camera so you can see. If we look down in here, you can see they're labeled, and the one I've got my finger on right now says ET temp, and then next to it we have BT temp. So this one is our ET temp right here. I'm going to hook up a new thermistor to it, and we'll see if we get a change on my readout. So I'm doing this live, and there's not really a whole lot to do with the electricity, but I'm going to unplug it before I start touching screwdrivers to it. I'm going to show you my computer screen right now. I'll plug this in so you can see what we're reading on the program for this. So this is the program for my, make sure I'm centered here. Upside down. There we go. So this is the program for my printer. And you can see over here that we have just a not available for the targets or for the temperatures. So this is the hot end. That's what melts the plastic. And then this temp 1 is the heated bed. So I'm just holding the printer right now. And we should start to see some temperatures pop up here. Do a little refresh and see if it pops up. There we go. So you can see the E temp is measuring at a -50. And the heated bed is measuring at 16.5 degrees Celsius, which seems about right. It's aluminum, so I'll put my hand on it right now, and you should start to see that 16.5 climb up here in a couple seconds. There, 16.7. So that's measuring kind of the relative temperature of my basement, but you can see that this -50 is definitely not right. And that's why we have to change out this thermistor. So let's go back. I'm going to unplug the printer now. Excuse the mess of my workshop. All right, and all the blinky lights should stop here in a second. All right. Now, before I start working on this, I do have it unplugged, but I just want to make sure that there's no residual power left on the board. So what I normally do is I take my multimeter, because we don't want to have any sparks. This is a multimeter, tells us voltage. And we're just going to measure the voltage of the power coming in, which is this one right here. And it is measuring at zeros. So we are good to go. There's no power left on the board. We can go ahead and start. Got my little screwdriver, and we're working over here. So I'm going to unscrew this one, unscrew that one. This one seems to be stuck. Bingo. Now, I'm not matching up where those wires came out of. They are labeled as a positive and negative, but the thermistor that I'm going to be replacing it with is not even labeled as a positive negative. And that's because it doesn't need to be. So we're just going to pull these wires back out of here as best I can, and we will worry about getting them all unattached later. Because when I did this, I braided them to make them look nice, which it does, and it helps with some organization, but it really stinks when you have to repair something. All right, let's get that one out. Almost done. One more wrap. Excellent. All right, so now we've got those outside of the bottom of the printer. So to make sure this works, I have a spare thermistor that I'm going to be putting in. Like I said, I've got the other one mounted. I'll bring that over in a second to show you. Maybe I'll bring you to it. But this is what they look like. So the end of this is a little glass ball, and you can kind of look up how these work, but it basically measures the resistance as the temperature changes. So there's just a little glass ball in the end, and this is going to sit right down at the very end of the hot end. If I can get the camera to focus. There. All right, and so we are going to take this part here, and this one is set up as like a plug option, but mine is not set up that way. So I'm just going to nip these off. My good cutters are upstairs doing a little electrical work in my house, so I got to kind of scrounge for usable materials here. All right, what do I do with those? Bingo, some side cutters. So we're just going to nip these off. I can always put another one on if I need it. And then we're going to go ahead and strip these. I don't need a whole lot of wire, and actually I don't want to overexpose the wire. Exposed wires on the bottom of a printer that's moving all the time, not a good idea. Okay, so these are actually solid core, so it makes it easy to work with. And we're going to go ahead and plug these in, and we'll see if our printer, if the problem is fixed. And if it's not, I really don't know what to do. We'll have to go back to the drawing board. But I am 90% sure this will fix our problem of negative 50 degrees. Oh, missed. All right, I gotta move these power supplies. Okay. So these things are actually a lot more simple. I mean, they're really complex machines, but in terms of building them and using them, the coding is all done for you. So if you've ever wanted to build one of these, the instructions are pretty foolproof. Have to have some basic knowledge, on how to strip wires and how to read a multimeter, but all those are easily figured out. and you end up with a homemade, homebrew 3D printer, and there are tons of websites out there devoted to this. All right, so those are both secure in there. Got the thermistor. We need to put your power supplies back down. Zoom back out here. Okay, so we are going to turn this on, and we'll see if we get any smoke or sparks. Got a blue light on my board. Should get a red light here that tells me that the printer is almost ready. The software is loading. And then I'll go ahead and plug it in. No red light yet. Software is still booting up. So this is a miniature computer down here, and it's got to do quite a few calculations. So as we wait for it to boot, we've got, this is the power in, this is the power to the board. You can see that they're really big terminals, and that's because it's going to take 24 volts to run these. Okay, I've got a red light flashing on my board, which tells me we are good to go. So let's switch over. Now, it's live, so keep in mind I might not have this right. Let's go back to the live stream, show you my computer screen. You get the nice mirror there. All right, so let's go over to Franklin, which is the software. Bingo. All right, so you can see over here that the targets are reading none. We're going to home the printer and refresh. And we should see some temperatures popping. Look at that. And we have our thermistor, that top number right there next to the E. This one right here is measuring at 15 degrees, which is pretty accurate. So the quality of the thermistor, I just purchased these off Amazon, so how accurate they are is, it's probably not going to be precisely accurate, like to the degree, but it's going to get me really close, and that's what I need. I need a read on the temperature so that my my hot end stays around the 210 or 220 degree mark for PLA, or the 240 degree mark for ABS. Now, if I'm going to hold this thermistor in my fingers, and you'll see those numbers start to jump up. Yeah, so as I hold this, we're up to 21.4. All right. I just breathed on it. So we can tell that that thermistor is working. So our fix is going to work for our printer. This is actually not the thermistor that I'm going to be using. The thermistor I'm going to be using is on my drill press over here, and I don't think my cable is long enough to get me there. I'll go see if it's dry for me to bring to you. If not, I'll show you what I did on a different one. All right, so the epoxy is not yet set, but here's what I did. So here's a spare heater block that I have. This heater block, this is what the extruder or the heat break screws into. So that goes something like, if I can get it to thread, that goes like this. And this is what does the drawing, and this heater core fits in the big hole here. You can see that. And then the thermistor that we just had, where'd she go? I lost it. There it is. The thermistor that we just attached is going to go in this little tiny hole here. Now on this one, you have to use it to set an epoxy. So we want that to be inside the heater, and you'll notice that it's really close to the extruder, or to where the plastic's coming out, and that's because we want to be able to measure what's the temperature at where the plastic is, not where the heater is. So that's where that's going to go, and I just filled that hole with a little bit of an epoxy, and in a couple hours she should be ready to go. It's got a 18 to 20 hour set on the epoxy I'm using, but because we're going to be heating it up, I'm guessing it's going to cure faster, and I'll be able to, and there's not going to be a whole lot of movement there, that I'll be able to use it sooner. So basics of 3D printer repair and how it works. Kind of fun.